For centuries, standard history books insisted on a single, unquestioned narrative about the Amazon basin, that before the arrival of European explorers in the 16th century, the rainforest was a vast, untouched wilderness, an environmental counterfeit paradise incapable of supporting large, complex human populations. The acidic, nutrient-poor tropical soils and dense canopy were believed to have limited ancient inhabitants to small nomadic hunter-gatherer tribes living in fragile, temporary shelters. But over the past few years, airborne LiDAR sensors mounted on low-flying aircraft swept across thousands of square kilometers of the Amazon, firing billions of laser pulses down through the dense forest canopy. The resulting three-dimensional digital elevation models stripped away the trees, exposing a reality that terrified mainstream archaeologists: a massive, sprawling network of pre-Columbian earthworks, geometric mounds, raised highways, and engineered garden cities hidden beneath the leaves, housing millions of people in a sophisticated, interconnected urban landscape that fundamentally rewrites human history. To understand why these LiDAR scans caused such shockwaves across the scientific community, one must look at the long-standing dogma that governed Amazonian archaeology. Throughout the 20th century, prominent anthropologists argued that the Amazon basin suffered from severe ecological constraints. Tropical rains leach vital nutrients like nitrogen and phosphorus from the soil, leaving behind reddish clay incapable of supporting sustained, high-yield agriculture. Without intensive farming, scholars reasoned, it was ecologically impossible for large, stratified urban societies to develop in the rainforest. Any evidence of large settlements was dismissed as temporary or accidental. However, historical records from early European expeditions told a completely different story, one that mainstream science spent centuries dismissing as hyperbole and myth. In 1541, Spanish explorer Francisco de Orellana led the first European navigation down the entire length of the Amazon River. His chronicler, Gaspar de Carvajal, recorded seeing massive, continuous towns stretching for miles along the riverbanks, featuring paved causeways, guard towers, intricate wood carvings, and agricultural fields capable of feeding tens of thousands of soldiers. Carvajal wrote that one could travel an entire day along the river without ever losing sight of inhabited settlements. When later explorers returned to the same regions decades later, they found only dense, impassable jungle and isolated tribes. Scholars assumed Carvajal had fabricated the story to secure funding from the Spanish crown. But we now know Carvajal was telling the exact truth. European diseases like smallpox had swept down the trade routes ahead of the conquistadors, decimating over 90% of the indigenous population in a matter of decades. With no one left to clear the land, the rainforest rapidly swallowed their cities whole. The first major physical clue that shattered the pristine wilderness theory was not found in stone ruins, but in the dirt itself. Scatterings of dark, nutrient-rich soil known as terra preta do Indio, or Amazonian dark earth, were uncovered across millions of acres of the Amazon basin. Unlike the surrounding nutrient-starved reddish clay, terra preta is deep, pitch black, highly fertile, and packed with biochar, charcoal, animal bones, pottery shards, and organic waste. Soil scientists discovered that terra preta was not a natural occurrence. It was an intentionally engineered biotechnological soil created by ancient Amazonians between 500 BC and 1400 AD. By burying charcoal at low temperatures alongside organic waste, ancient farmers created a porous soil matrix that retains moisture, prevents nutrient leaching, and continues to regenerate itself for over 1,000 years. This supersoil allowed ancient populations to conduct high-density, sustainable farming directly beneath the jungle canopy. Proving that early societies did not adapt to the harsh Amazonian environment, they systematically re-engineered it. While soil chemistry proved the existence of agriculture, the true scale of the urban infrastructure remained invisible due to the impenetrable forest canopy. Traditional ground surveys could only map a few dozen square meters a day using machetes and GPS, making a regional survey impossible. Enter light detection and ranging, or LiDAR. By emitting hundreds of thousands of infrared laser pulses per second from an aircraft toward the ground, LiDAR technology measures the microfraction of light that slips between leaves and branches to hit the solid earth beneath. Algorithms then filter out the vegetation point cloud, generating a bare earth 3D digital elevation model that reveals every subtle mound, ditch, road, and platform hidden beneath the forest floor. When researchers scanned the Upano Valley in eastern Ecuador along the eastern foothills of the Andes, the LiDAR returns revealed a subterranean urban network that left archaeologists speechless. Beneath the trees lay a dense complex of over 6,000 rectangular earthen mounds arranged in precise geometric patterns surrounding open plazas. These mounds, built between 500 BC and 600 AD, served as the foundations for ceremonial buildings, communal halls, and residential homes. Connecting these mound clusters was a staggering network of wide, straight, sunken highways and raised causeways stretching for miles across valleys and rivers. The spatial density and organization of the Upano Valley rivaled the complex urban planning of classic Maya cities in Mesoamerica, representing an urban tradition that persisted for over 1,000 years before vanishing. Farther south, in the Llanos de Mojos region of the Bolivian Amazon, LiDAR scans conducted by international research teams revealed another form of ancient urbanism, low-density garden cities built by the Cassarabe culture between 500 and 1400 AD. The scans mapped massive monumental sites featuring 16-foot-high earthen pyramid platforms, elevated circular enclosures, and massive artificial reservoirs used for fish farming and water management. Radiating outward from these central civic ceremonial hubs was a vast web of straight, raised causeways extending up to 6 miles each, connecting primary urban centers to secondary regional settlements. The scale of earth moving required to construct these causeways, canals, and platforms required a central labor authority and complex political organization that scholars previously swore could never exist in the Amazon. Even more shocking was a sweeping LiDAR survey published in 2023 that analyzed random, unexcavated patches of the southern Amazon margin in Brazil. Using predictive AI spatial modeling, researchers calculated that over 10,000 ancient earthworks, including monumental geoglyphs, fortified ring-ditch villages, and defensive moats, remain hidden beneath the canopy across the Amazon basin. The data indicates that pre-Columbian Amazonia was home to a thriving population estimated between 8 and 10 million people. Supported by a sophisticated mosaic of agroforestry, engineered soil, and interconnected river trade routes. The implications of these discoveries extend far beyond history textbooks. They fundamentally alter our understanding of human ingenuity, climate management, and ecological design. The ancient inhabitants of the Amazon did not destroy their ecosystem to build concrete megacities. Instead, they created a sustainable, living infrastructure, a garden urbanism, that integrated food production, forest management, and civil engineering directly into the natural environment. As high-altitude LiDAR aircraft and satellite radar arrays continue to sweep across the remaining unmapped sectors of South America, the myth of the pristine, uninhabited Amazon rainforest is officially dead. What was once thought to be an untamed wilderness is proving to be the world's largest abandoned metropolis, a vast, engineered landscape waiting floor by floor, scan by scan, to be brought back into the light of day.